Hey everybody, let's give this problem a try. So we have this inductor here, and we're saying that this switch has been closed for a long time, right? So that means whatever current was coming this way, right? Then if it kind of splits off like this, if the switch has been closed for a long time, all of these currents are constant. And then for an inductor, remember that the voltage across an inductor is L di dt. And if this current is constant, then the time derivative is 0. Right? And if this is 0, then L times 0 is also 0. So the voltage across here is 0, which is the same as saying like it's like a wire, right? It's just a short. Which means if you just take a look at this node, see this current? All of it goes here, and none of it goes here, right? So there's no current over here at all. Right, so the circuit basically looks like this, right? If I just cross all this out. Okay, so let me just draw that. And then, right, just a wire. How about I move this over here? And we want the current going, I mean, the inductor is here, right? Behaving like a wire. And we want the current going through that inductor, at least before at t equal to 0, approaching from the left. So what is this? Okay, so how much current is going this way, this way? As far as this voltage source is concerned, it looks like some equivalent resistance, right? So what is this equivalent resistance? It's, oh, I forgot this one over here. Okay, it's 2 plus 4 plus, right, 2 plus 4 plus these two in parallel. So whatever 18 and 1.5 in parallel is. 18, 1.5, and then take the reciprocal. Okay, so just punch this up in the calculator. That's the equivalent resistance. So what is the voltage? 48 over here. So the current here, over here, right, is just V over R. So IL is V over R. So, and then it's kind of upside down, right? So minus 48 over whatever this equivalent resistance is. Okay, so now we know this is at t equal to 0. Okay, and for an inductor, it's impossible for current to change instantaneously. So this is also IL at t equal to 0 immediately after you open the switch. Okay, and then what happens? Whatever that current is, when we open the switch, so this is whatever it was at t equal to 0, it's gonna go like this, right? Okay, so we want, I'll just write, I'll work it out really quickly. So for the voltage, now, let me erase. Okay, so when we open the switch, we're only focusing on this part now, right? Because now this is gone after we open the switch. So it looks like some inductor and then some equivalent resistance here, which now this equivalent resistance is 12.45 plus 10 plus these two in parallel. Plus 10 plus those two in parallel. Reciprocal. Okay, so just punch that in the calculator. And then the voltage looks like L di dt, and then the voltage here is IR equals 0, and then just move this on this side. Divide both sides by L. Okay, and then this dt and this I can trade places. So they can trade places. Let me write this a little nicer. Okay. All right, and then we can integrate both sides from I naught to I, from T naught to T. T naught can be 0. All right, so this is natural log, and this is minus R over L, T minus 0, so T, right? And then e to the log, e to the that, cancels that. So then I, this is for the inductor, as a function of time is initial e to the minus R over L, T. And this R is this equivalent resistance we just got there. The inductor L is given, 0.5 henries. And then the initial, this is this. Okay, but that is for the inductor, which is here. Okay, so let me just take a focus our attention on this, right? So that expression here is for over here. But then we want the current here, right, is the question. So, right, this is over here. So just think of it as it is a current divider. Right, whatever current is going over here, I, L, some of it goes here, some of it goes here. Right, so then this current is only some of this one, and it's the current divider. So can I just squeeze this in over here? Right, so then this is 54 ohms, and this is 26. So the current here, O, is IL, which is right below, and then current divider. So 54 over 26 plus 54. Okay. And there's the answer. Plug this in over here. Okay, that's all. All right, so I hope that's helpful. Keep on practicing. I'll see you in the next video.